Hi everyone, and welcome on the Open Spring INSPIRE Hackathon. We are the team one, the first challenge, which is called How to Use and Improve Open Land Use and its second version. The main aim of our challenge is to verify and test the possibility of using the second version of the geographical database Open Land Use for different areas of human activity and also for commercial applications, which means real estate, investment evaluation, etc. And also the second aim is to support the use of the open land use in various areas, gathering data for further development of the OLU database. Our team consists of team mentors Karel Charvat and Kristina Čerbová, and also from our developers, which is Michal Kepka, Dima Kožuch and Pavel Hájek. Both of them are from the West Bohemian University. So what to say the next? The hackathon provides opportunity to test the new Open Land Use database and new designed and still developed version of Open Land Use. And the main work is to test and test and test and again. Opportunity to cooperate with other teams on both ways, which means on the other hand, to provide data from Open Land Use database, but also on the second hand, to integrate results of Open Land Use database. And also we had in our team of Challenge 1, the consultants for cooperation, Otakar Čerba and Herman Schneeweiss. I would like to give the floor for the main speaker and the first speaker, which is Michal Kepka.
Thank you, Kristina. I will try to share my screen. It should be visible. Okay, I would like to introduce the main goals and subtopics of the challenge. So we were trying to verify the new Open Land Use database. As Kristina mentioned, it was new version of the database. It was designed and developed since spring 2020. And we were trying to cooperate with other challenges on both ways for providing and integrating of data. The main topics of this challenge can be divided in three categories. First was generation of new reference geometries, or the method of generating reference geometries. For these reference geometries, it means that all these thematic layers are integrated in these geometries. The second topic is hierarchical and harmonized administrative boundaries layer. So how to classify OLU features to different administrative units worldwide. So to be able to really classify and filter by administrative units. And last but not least topic was initial development of Open Land Use second generation in Africa. So we are trying to integrate in the new data model features from available data in Africa, from open available data, and utilize Earth observation data sources to improve this Open Land Use. So to the first topic, reference geometries, what is it? In database, we have different data sets integrated, and some of them are mainly, let's say, thematic layers that provide just the thema, not mainly how it is distributed and how it can be visualized. And the second type of data are these, let's say, general or reference data sets. These data sets accept own thema, for example, cadastral or field blocks, provides this location functions for this thematic information that can be integrated in this general layer. So we were selecting reference geometries for every level of this Z value object that we defined for Open Land Use. And we were trying to integrate different thematic layers in different levels. So in every level of Z value, we have reference geometry and connected thematic layers. In case of generating this consolidate reference layer or reference geometries layer, we can omit geometries that are completely covered by other geometries. So it's mainly used for improving of visualization possibilities and publications. So it's publishing less data than in full version. So it means we can provide effectively WMS services. In Open Land Use, we have defined two types of reference geometries layers. We have, let's say, general reference layer that really follows this Z-value hierarchy when these most detailed layers are on the top, and on the bottom there are the less detailed reference layers. Or the second type is, let's say, thematically defined reference layers, where user or this target view defines how to order these reference layers in this stack. So some of these reference layers from the stack can be omitted, some can be skipped, and just to order according to needs of the user. So some examples, this is example of this general reference layer where we have layers ordered from, let's say, most general core inland cover to urban atlas, cadastral data, and field blocks. On the left side, you can see intersected attributes. And this is example of view defined reference layer where the order is defined on, let's say, local detailed data. And this hierarchy has more attributes that are connected. These attributes are from Earth observation products. So it's one of these advantage that you can integrate just to geometries you would like to have. Okay, that's all from my side, and I would like to give the floor to Pavel.
Thank you very much. And we wanted to have a delimitation of regions or areas of interest for our open land use database. So we got together a so-called administrative unit object in our data model. It's a hierarchical and harmonized data set of administrative boundaries from different kind of data sets. That's why it's harmonized. And hierarchical means that every feature in the object knows its parent if it has some. So we wanted at the first time to find an appropriate data set which covers the whole world, to start with administration level 0. We had some requirements on the data, and we searched for many of such data sets and data providers. At the end, we found out this natural Earth data set, which consists not only from administrative boundaries, but there is two different kind of administrative boundaries, one for level of 0 and the second for level of 1, representing the whole states or countries and regions. As you can see on the slide, on the left side, there are two red polygons. The large one represents the Czech Republic, which is number 830 in the table on the right side from the map. This is the administrative boundary for the whole Czech Republic, so it has no parent feature ID. But the smaller red polygon on the left map, it's just a region of the state, so the parent feature ID is the Czech Republic, and this is the hierarchy in the data. even though we wanted to have one global dataset covering the whole world, we know and we are aware of the situation that there are local datasets which are more precise regarding the administrative units. And that's why, because the natural Earth dataset consists of data in a scale of 1 to 10 million.
Local data from nationalities
are more precise and denser than the dataset we use as a general one. So we know that we will be replacing the geometries for a particular area of interest with local datasets usually provided by the local authorities with more detailed data and with higher level or lower, depending on how you look at it. For example, in Europe, we know that there are the data sets of nomenclature of territorial units for statistics, aka NUTS, which covers administrative levels from 0 to 3, and local administrative units in Europe, which covers level 4. And this is the yellow example on the right side. This is the dataset of local administrative units, while the black borders are from the dataset of natural Earth already implemented in administrative unit object of Open Land Use version 2.0. We are getting to the results of our challenge. This is the example for a particular part of Africa, but this is just a static example. And we are getting to the end of, let's say, theoretical background of our challenge. And I would like to give a floor to my colleague Dimitri, and he will show you a live demonstration of Open Land Use 2.0 database and what data can be incorporated and what data are available. So thank you very much for your attention from my side, and I will give the floor to Dimitri now.
Thank you very much, Pavel, for introduction. So maybe here I will show some practical output of what has been created in this challenge on example of open land use for Africa. As you know, the situation with open data in Africa, it's not the same as in Europe. In Europe, it's very easy to get reference geometries as, for example, Michael was explaining about this reference geometries. There are cadastral parcels available in many countries. It is LPs available in many countries, but in Africa the situation is not the same. So basically, our task was first task was to create the reference geometries by ourselves. So what we did is we downloaded some linear features, then we downloaded some polygonal borders from OpenStreetMap because it appears to be the only data source, basically vector data source that covers the whole Africa. And then also we incorporated in it the borders from administrative data set with the provinces about which Pavel was speaking. So basically all these three line works, they were merged together, and then the gaps between the lines that have formed, they were filled, and in this way the reference geometries were created. For example, here you can see WMS layer that displays the borders of all objects, and you can clearly see that basically it is based on OpenStreetMap features, but here also you can see that border that comes from the administrative borders data set Pavel was speaking. The division by borders, it was done because to process the amount of data for the whole Africa at once, it's impossible. So we need to go unit by unit in these calculations. So after the borders were defined, we started to look for sources of data for the whole Africa, on basis of which we can calculate some thematic attributes. The most important for us are land cover and land use. So we have found this data set developed by ESA. It is basically based on satellite imagery, and it displays land cover of the whole African continent in resolution of 20 meters. It is raster data set, and basically now the task was to calculate which is the most prevailing land cover type in each of OLU reference geometries. So it was done, and here is the result. You can see maybe if I so, for example, here you can see that the red color build-up area is the most prevalent. So basically, if we take the reference geometries, those are red. In river also, I think it is quite clear that the blue water land cover is the most prevalent. And in some territories which are marked in purple, for example, let's take this. Those are typically bigger reference geometries. It's a mixture of everything, and everything takes about, I don't know, like from 10 to maybe 30% each of category pixels. So those areas were colored in purple as being mixed surface. And here maybe I can show you the demonstration of all countries calculated in such way. We somehow focused on the countries in East Africa this time. So we have it calculated for Uganda, for Kenya, for Rwanda, Burundi, and also for Tanzania. So if I will zoom out, you can see this map. And basically, it was also code developed that is basically some code in Python. Some dependencies include certain common Python libraries to work with geospatial data and Postgres database. So it's, let's say, 126 lines of code that allows you, if you download data from OpenStreetMap and some semantic raster, so it will allow you to generate such data set for any country. Yeah, here we're in this. WMS first attempt, taking into account that data in Africa it's not available. It was quite a good result in the end. So. And also, maybe it's needed to say that within this challenge, we collaborated with other challenges, with challenge 2 and with challenge 6 by providing the calculated data for OLU reference geometries. I think it's it from my side. So thank you for your attention. And once again, if you would like to know more, maybe you can read this report. It's more detailed, or you can also go to this hub, Smart Afri Hub, and all of the maps are available as map compositions there. So you can just open it in your browser and check it for yourself. Thank you very much.
Okay, so thank you very much, you two. This was the brief introduction of the second version or second generation of Open Land Use, and the team of our developers presented to you the basement of this geographical database, as well as the live demonstration. We hope you are satisfied with this presentation and also with our job, because it was a hard job. Bye, and see you at the next hackathon, which is planned for this autumn. So bye.